Class.
Yes.
Okay, today we are focused on pure substances and
Mixtures.
Okay, pure substance. A pure substance is made up of only one kind of
Material.
and the same properties are present throughout the substance. A pure substance is made up of one kind of element or one kind of
compound.
Pure substances include both elements and compounds. A pure substance contains only one type of atom or compound. A pure substance cannot be
Physically.
separated into different parts. It always have the same
Physical.
and
Chemical.
properties throughout. Distilled water is a
Pure.
substance because it cannot be broken down into simpler parts by
Physical.
separation. Or other examples of pure substances are
Silver.
iron fillings, sugar, and
Salt.
all of these are only made up of
One.
kind of element or compound. How much is the element what? Worth?
One.
If you notice, I keep magnifying what? One, because I need you to make that correlation. Then we have mixtures. How many types of mixtures do we have? What are they?
Heterogeneous, homogeneous.
And homogeneous. Good job. Mixtures are made up of two or more
Pure substances.
that are not chemically combined. Because they are not chemically combined, the pure substances retain their own individual
Properties.
of matter. Mixtures can be separated by
Physical.
means such as
Filtration.
filtration. Say it with me. Filtration.
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 Or distillation.
Distillation.
Say it with me. Distillation.
Distillation.
Good job. A mixture can be a
Solid. Liquid. Gas.
or a combination of different states of
Matter.
Many mixtures can be found in
Nature.
muddy water in a river is a
Mixture.
of solids and
Liquid.
the atmosphere is a mixture of different.
Gases.
The layers of the earth are made up of different mixtures of rocks, and many rocks are mixtures of different
Minerals.
Good job. So we just got through talking about pure substances and mixtures. What are they taking us into now? I have a question. Are elements and compounds still considered pure substances? Yes. And where can we find our pure substances? On the periodic table. If it's not on the periodic table, is it a pure substance? No, it has to be a mixture. Thank you. The difference between a mixture is that it's not chemically combined. Whereas a pure substance is chemically combined. So a mixture is not chemically combined, whereas a pure substance is what? Chemically combined. I need you to hold on to that. Elements and compounds. All matter is made up of atoms. This includes both
Living.
and
Non-living.
atoms can exist as either elements or compounds. So when we went through organelles all the way down to our mixtures, we literally went from non-living to the living things. So good job. Atoms are the building blocks of all
Matter.
Whereas you think about it, you learned that cells are the building blocks of life, right?
Yes.
Notice that correlation. Elements and compounds are both made up of.
Atoms.
There are also examples of matter that are.
Pure substances.
And pure substances are a type of homogeneous matter that is made up of only one kind of material. Pure substances are the same throughout, and all of the particles in a pure substance are exactly the
Same.
because they are the same types of atoms. Copper,
Oxygen.
water,
Sugar.
and
Table salt.
are all examples of
Pure substances.
elements. Elements are the simplest pure substance because they are made up of only
One.
type of atom. All of the atoms of a
Single.
element are very similar to one another. For example, all atoms in the same
An element.
contain the same number of.
Protons.
What charge do the protons carry?
Positive.
Good job. Protons in their nuclei. The number of protons in the atom is called the atomic.
Number.
Elements are represented by chemical.
Symbols.
Each symbol is made up of one,
Capital letter.
which may be followed up by two lowercase letters. Here are some examples of elements and their chemical symbols. Put your eyes on that so you can see. Hydrogen got the capital H. Iron has a capital Fe. If you notice, iron and Fe they don't go together. All capital letters is not a reflection of the what the letter began with, what the element began with. However, we know that it's only one element because of what? It's only one capital letter. Good job. Are we counting lowercase letters? No, they are not a reflection of an element. Then we have carbon and we have oxygen. Remember I said by the 8th grade they want you to know at least 10 of these elements by heart? If you notice, these are some of the same elements that keep coming back around, right? Make sure you're holding on to them. Let's go to the one that has the periodic table on that page. Since individual atoms are the basic unit of
matter,
the atoms of an element cannot be
separated
into smaller parts by normal chemical
reactions,
A pure
element
may change in appearance by
melting
or
dissolving
in a solution, but the atoms themselves do not break.
apart.
All of the known
Elements
are represented on the.
periodic table.
There are over 100 different types of.
Elements
So if you notice on that display they gave you, you notice the categories, the metal, the metalloids, non-metals, and the unknowns. I'll make you familiar with that, but notice how they have them categorized. Each element has a unique atomic number, name, and symbol. In addition, each element has unique properties that make it different from any other element. And then you go into your compound. What are compounds? Two or more elements. Good job. A compound is a that is made up of or more
different
types of.
atoms,
When atoms of two or more
elements,
combine to make a,
compound,
the compound has different properties than the original.
elements,
Living organisms and most living things are made up of different.
compounds,
Once the elements in the compound are chemically combined, they do not separate easily, but they can be separated by a.
chemical reaction,
This means that breaking down a compound is a.
Chemical change.
A compound is represented by a,
chemical formula,
which shows the number and type of elements in the.
compound,
A chemical formula is a combination of the chemical symbols that represent each
element,
and numbers that show how many
atoms,
of each element are in the compound. Here are a few examples of compounds and their.
chemical formula,
So let's look at the first one. I told you they will always give us water, H2O. All of the things that they give us, water is like the basis. Even when we're doing our states of matter, they'll add other things, but they expect us to know the properties of water. And then we have carbon monoxide. Who can tell me the difference between carbon monoxide and carbon dioxide? Look at it. Come on. Who can I reward out for that? What's the difference between?
Capital letters?
It's 2 capital letters in carbon dioxide too. Yes, Yara.
Carbon dioxide has 2 oxygen.
It has 2 molecules of oxygen. So instead of it reading CO, it will read as what?
CO2.
CO2. You need to know the difference. Carbon dioxide is what we breathe out. If you breathe in or intake carbon monoxide, it is a silent killer. If you cannot smell it, it's a invisible gas, and you will go to sleep and not wake up again. So it's very important that you know the difference between CO2 and CO. CO is the representation of carbon monoxide, whereas CO2 is carbon dioxide. Got it? And then you have potassium chloride. Does potassium start with a P?
No.
What does it start with?
And
Okay, so again, notice that the actual element may not be a reflection of the chemical symbol. Then we have ammonia. Does ammonia start with A?
No.
No. And you don't see any element within it that start with A. So notice again that those elements can be reflected by another capital letter. The compound carbon monoxide, look at those molecules. Molecules of the compound carbon monoxide contain 1 atom of carbon and 1 atom of oxygen, whereas carbon dioxide is 1 atom of carbon and 2 molecules of oxygen. Got it? So we are finished. I am coming around with our 10 questions, and in those 10 questions, you will work together as a group. Now, TDQs, text dependent questions. Are we making up our answers?
No.
Are we guessing?
No.
What are we doing?
We're getting
We are relying on the text. We are not writing on our articles, but we can write on the question sheet. Put your name and date because this is a grade. Make sure that you know the difference between a pure substance and a mixture, and all of the things that they're asking you about is within that article. So again, you do not have to guess. You are dependent upon the text.
Miss Baker.
Yes.
More.
Okay. Gotcha.
What's her name?
Class. Yes. Let's look at number 1. It says, which of the following is an example of a what?
Pure substance.
A pure substance. So when we think about the first one, which is a salad, will we choose that one?
No.
Why?
It's a mixture. You can't find on the periodic table.
You cannot find it on the periodic table. Thank you. When we think about sugar, is it a pure substance or a mixture?
It's a mixture. You can't find it. You can find it.
It's a compound actually, and you can find that on the periodic table. And instead of guessing, what Anthony should have done? Go back to the text. When we don't know something, where are we going back to? The text. Are we guessing?
No.
Are we making up anything?
No.
So I want you guys to go and see where you can find that pure substance is a sugar.
Yeah, it's on the third paragraph. Sorry.
It's in the 3rd paragraph on the 1st page. Thank you.
Salt.
Salt water. Pure substance or mixture? Salt water. Pure substance or mixture? Mixture. Are we guessing?
No.
Where did we get that from? All you gotta do is look in the text. The salt water is a mixture. It's one of those solutions. So a solution has to be what?
Mixture.
A mixture. What type of mixture? Homogeneous. If salt water is a homogeneous mixture, if we had water and we had salt, which one is the salt? Is it a solute or a solvent? A solute, because it what?
Gets dissolved.
Gets dissolved. So the water would have to be the what? Solvent, because the water does what? The dissolving. Good job. And so the last one is cake batter. Is that a pure substance or a mixture?
Mixture.
Mixture. So A, B, C, or D. Which of the following is an example of a pure substance? Which one should we have chosen?
B.
I'm hearing 2 different ones.
B.
Raise your hand if you think it's B. Raise your hand if you think it's C. Okay, the majority chose B. For you guys that did not raise your hands, you're not relying on your neighbors. I need you to use your own cognitive abilities. And so for that, the answer is B. A pure substance is sugar, because it's called C and H. Unfortunately, you guys are a little too young to remember that pink bag of sugar that has C and H on it. And it's basically just a chemical formula for sugar. And so the next 9 questions you are going to do as a group at your table. And let me ask you this. Are we making anything up?
No.
Where are we getting our answers from?
The text.
The text. So we're not guessing. We're relying on our text. That's what you call text-dependent questions. Come on, get started. Meaning I should hear conversations. This is not a quiet assignment. I should hear you talking about the material.
It has the same chemical properties as well. Yeah, number Thursday, right? Oh, I don't know if it's made of hydrogen. Yeah. It has a formula of H2O. How would the mixture of hydrogen